Hi guys, it's me Messi from Messi's Maths, and today we are here to talk about logarithms. Okay? Now, before we talk about logarithms, let's talk about squaring and square roots. Now, initially, what some of you at least, or most of you most likely, may have understood of squaring as the reverse, square rooting as the reverse of squaring. Well, it's not the exact reverse because square rooting always has two roots. In reality, there are always two roots, but we tend to take the positive root. So think about it like this: if you take the graph, yes, but if you take the graph y squared equals x, see, there's a difference. So in this graph there's only the positive values, but in this graph you have the positive and negative values. Now, why this graph is not shown is a different thing. Let's not talk too much about that. But moving on, let's go to logarithms. So x to the power n equals 4. Okay, let's take like 2 to the power, let's take 2. 2 to the power n equals 4. Okay, so what we do, the log is considered. I'm not sure if it's exact, but it's definitely considered. Let's see if it's exact and come to think about it. Now on decimals it's a bit difficult, but what should go down here is there should be a base to this, which for some reason it's not showing, unfortunately. But yeah, just trust me on this one. Let me show you with the whiteboard. Thankfully we have that. But you see, one thing we can do to show it, actually, yeah, that's basically the only thing you're supposed to do to show it, is forget this. Okay, okay, the first it will, I'll call it a base. Okay, log base 2 is considered for wait, there should be something in here. Log base 2 of 2 squared is equal to 2. Now let's remove this, and if we were to replace it with 3, that's basically what it would be equal to. So the log base 2 of 8 is 3. Okay, just to check, let me see the function 2 to the power n, or 2, actually let's take 2 to the power x, because x is where they considered. Okay, there you go. Let's also see let's also see 10 to the power x. By the way, if you see log just on its own, it's base 10. If you see LG, it's base 2. So remember this. Okay, log okay, log of x, just log, is when is base 10. Okay, sorry for the time it takes, but let's just go on with it. LG can be considered to be base 2. Okay, this is a bit ugly, unfortunately, but you can, if x were to equal 2 to the power 3, yeah, it would go to this. Okay, so LG of x corresponds to log 2. Right, and finally ln is how I've heard people say it. I call it ln. Well, I have called it ln, but yeah, it equals the log base e. And you might find it weird, why would you have a log base e, but Just go with it for now. Okay. So basically what you can do with a log, like let's take a formula. Okay. Right. Okay. So if you take a formula, so if you take half-life, okay, the amount of particles remaining, it's a bit odd. Sorry about that. The amount of particles remaining, alright. Let's say the remainder particles, just to be more accurate, equals the initial is equal to the initial over 2 to the power t over h. Okay, so what we can do, okay, so this might be nice if you just want the PR. Okay, so if it was like if there was an element with a half-life of 8 seconds and there were 2000 atoms in the beginning, even though well, it works for grams, but it does work for grams, and I'm not sure about moles, so let me check that later. But if there was somehow 200 atoms of of something that had let's say a substance that had a half-life of 8 seconds, then so how do you do it after 16 seconds? Wait. How many electrons would there be? No. How many atoms would there be after 16 seconds? Right, so you basically input it in. Did I say 200? Okay, let's take a different answer. Sorry, I forgot. If there were 200 atoms of a substance with a half-life of 8 seconds, right? How much would there be after 16 seconds? So that would be, in this case, okay, over 2 to the power 8 over 16. And here would be 200. I said 200. Okay, and 8 over 16 equals, wait, sorry, it's the other way around. 16 over 8. Okay, 16 over 8, thankfully. Otherwise that would have been a square root. Okay, so that equals 2 squared, which equals 4, okay? So there'd be a 4. Sorry about that. But 16 over 8, okay? And that equals 16 over 8 equals 2. 2 to the power of 2 equals 4. And 200 over 4 equals 100 over 2, which is 50. So 50 atoms. So even if that's really easy, because 16 is 2 half-lives, what if they asked how much was there after 15 seconds? Okay, now this is a bit off track, so let's do that on another video. By the way, if it was after 15 seconds, you could just plug it into the formula. Okay, so don't worry about that. But okay, even if that might be nice. What if there was a question like a part an element with a half-life of, wait, no, no, a substance had, if an imaginary substance had 200 atoms, not electrons, sorry, 200 atoms at the beginning, 40 atoms at the end, and okay, wait, and if this number was reduced to 40 after a period of 15 seconds, how would you find the half-life? Okay, so we input them here, the remainder is 40, okay, and the initial is 200, even if it's imaginary, and 2 to the power 15 over h. Okay, now if you didn't know about logarithms, whether you could or could not, still it's just best to use, it's just, why wouldn't you use logarithms in this case? So what you do is 2 to the power 15 over h equals 200 over 40. Alright, so okay, equals 200 over 40, and that okay, let's just simplify on the on screen. Okay, so you can remove this to be, you can cut this and cut the 4 and keep it 1. Okay, 10 over 2, 5. Okay, 5. Now you could do this with basic algebra, but how do you do the rest? Well, you can. I'm gonna give it to you. You could take the h power of each and take the h. No, you see. Actually, never mind. Let's not do that. This is logarithms video, so let's just do the easy way. Let's say LG. Okay, because remember LG equals log base 2. Okay, so LG of 5 equals 15 over h. Okay, equals 15 over h. 15 over h. Now remember, I don't know the half-life myself. So to find the half-life, what we can do, what's going on? Okay, to find the half-life, we can just, so the half-life equals 15 over LG5. Now I'm not sure if LG5 works, if LG itself works on Desmos, but unfortunately as well, I don't personally know what LG5 is myself, so let's not go there. I mean, I could estimate what it's greater than, actually no, what's less than, but let's not do that. Now let's first try to find, no, it's not there. Okay, sorry. Let's see if LG works. Can I press it? Nope. Sorry. Let's do it like this. 15 over LG 5. Okay, so 15 over LG 5. Okay. Since we can't do subscript on the Google search, let's just do 2. Yes, let's do 2. And there you go. I have actually no. Let's bear with me, people. I have no idea how I managed to calculate this, but oh, finally. Okay. Oh, thank you. Okay. Anyways, let's just don't think too much about that, and let's finally calculate. So it'll be 15 over. I haven't found out how to do this with only the keyboard yet, so bear with me. Okay, it'll be over LG5. Wait, yeah, LG5. But since there's no LG in here, we're just gonna have to find log with the base of n, which will definitely be here. Oh wait, a. Okay. Okay, it's equal. And that's the half-life. Of course, let's hope. I think. Let's see if this is in seconds. Yep, that's in seconds. And this was not really in a unit, it was just 200 in a proper unit, not really a psi unit or anything. 200 atoms, that's just it. And PR was also in atoms. Yep, it was in atoms. And this one was 15 was in seconds. And 15 over LG5 should be seconds. Okay, so this is correct after all. And that's how you solve this. Please like and subscribe. Vote on the community tab. And see you next time. But before you go, bear with me. So I should edit my videos eventually, add thumbnails, and have some better quality. So coming soon, alright? Don't worry, don't expect everything at once, please. But we'll work on it.